All right, let's talk about something that's kind of like the unsung hero of the entire Java ecosystem, packages. We're going to dig into how this whole system of imports and folder structures is actually the secret sauce that brings order to some of the biggest software projects out there.
So let's get right into it. If you've ever dipped your toes into Java, I bet you've asked this exact question. Like, why is it so picky about where I put my files? Why all these strict rules about folders? It can feel super frustrating at first, right? But trust me, there's a really, really good reason for all of it.
And that reason? It's all about scale. I mean, think about the giants of the tech world. We're talking about massive enterprise frameworks like Spring Boot, the entire Android operating system that's probably on your phone right now, and even huge games like Minecraft. Every single one of them depends on this strict package system to even work. It's not just some friendly suggestion, it's the absolute foundation they're built on.
Okay, so let's try to look at this a different way. These aren't just annoying rules meant to slow you down. No, they're a deliberate, thought-out design feature. So let's break down what a package really is and why it's so crucial for writing solid, professional Java code.
You know, at its core, a package is really just a logical department for your classes. Think about it. A company wouldn't just cram all of its employees into one giant, chaotic room, right? Well, Java does the same thing with its code. It doesn't want you to just dump everything into one big folder. It's all about bringing a bit of order to what could otherwise be total chaos.
This analogy here is actually perfect for getting your head around it. Imagine your entire project is a company, okay? Now, each package is like a department in that company. You've got your HR, your finance. In Java, you've got java.util, which is kind of like the utilities department, or java.net for all the networking stuff. And every single class file? That's like an individual employee hired to do one specific job. Make sense, right?
So, how does this whole company idea actually become a blueprint for order? Well, it's because this structure isn't just about keeping things neat and tidy. It actually serves a bunch of critical functions that make building huge software projects even possible in the first place.
See, the key takeaway here is that packages are doing a ton of heavy lifting behind the scenes. They're not just organizing your code into nice little piles, they're actively preventing chaos. They stop developers from accidentally creating two classes with the exact same name, and they act like security guards controlling who gets to access what code. Without this system, trying to build and maintain a big project would be a complete nightmare.
And here's a perfect real-world example of why this is so important. Think about a banking system. You absolutely do not want the code that handles logging in and authentication to get mixed up with the code that processes payments. No way! By putting them in separate packages like com.bank.auth and com.bank.payments, you create these secure walls between them. It lets different teams work on their own parts without tripping over each other and prevent some really dangerous accidental mix-ups.
All right, now we're getting to the part that feels the most rigid, the part everyone bumps into. We're talking about the specific, non-negotiable rules about how you name things and how that name is tied directly to the folders on your computer.
So here's the golden rule for naming packages in Java. It's called reverse domain naming. Now, why reverse? It's actually pretty clever. Your website's domain name, like google.com, is guaranteed to be unique in the entire world. So by flipping it around to com.google, you create a package name that is also globally unique. It's a simple trick to make sure your code never clashes with someone else's, no matter what library you pull in.
And this right here, this is the unbreakable link. That little line at the top of your Java file, the one that says package, that is not just a friendly suggestion or a comment. It's a command. If your file says package com.yourcodebuddy.core, then Java demands, it requires that the actual file is sitting inside a folder path that looks exactly like this, src/com/yourcodebuddy/core.
And listen, there is zero wiggle room on this. If that package name and the folder path don't match up perfectly, your code just won't compile. That's it. It's a super strict rule, but it forces a kind of discipline that makes sure the logical structure of your code and the physical layout on your hard drive are always in perfect sync. Okay, so we've organized all our code into these different departments. That's great. But now, how do we get the employees from, say, the finance department to talk to the folks over in HR? In other words, how do classes and different packages actually communicate with each other?
Well, you could do it like this. Every single time you want to use a class from another package, you could write out its full name, its fully qualified name. So to use an array list, you'd have to type out java.util.arraylist every single time. I mean, it works, but man, is it messy and really hard to read.
Exactly.
Can you imagine reading and writing code like that all day long? It would be a total nightmare. There has to be a better, more elegant way to just tell our file, hey, these are the classes I'm going to be using.
And of course there is. It's the import statement. It's so simple. By just adding import java.util.arraylist to the top of your file, you're basically telling Java, hey, I'm going to be using the ArrayList class in here, so just have it ready for me. And just like that, you can use ArrayList directly. Your code is instantly cleaner and so much easier to read.
Packages also team up with something called access modifiers to control who can see what. You've probably seen public before. That means anyone and everyone can see it. And private means only the class itself can see its own stuff. But the interesting ones are in the middle. If you don't type anything at all, that's called default access, and it's actually package private. That means it's only visible to other classes inside the same package. This is a super powerful way to hide the nitty-gritty details of how something works from the outside world.
Okay, let's pull all of this together now and see how packages solve some really common real-world problems that developers run into every single day.
So here's a classic problem. Let's say you're building a huge application that has both a banking system and an online shop. The banking part of your code needs a class called user to handle authentication. But wait, the shopping part also needs a class called user to handle customer information.
So you've got two different classes, both named user. Uh-oh, now what? If you just threw all your files into one big folder, how on earth would Java know which user you're talking about? It would be total chaos, a massive name collision. But with packages, the solution is so simple and elegant. The bank user's full name is actually com.bank.auth.user. And the shop user's full name is com.shop.customer.user. See? The package name acts like a last name, creating a unique identifier that completely solves the problem. It's how packages prevent that naming chaos.
And you know, it goes way beyond just solving problems like that. Modern frameworks like Spring Boot actually use the package structure to understand how your application is built. When you start a Spring Boot project, it automatically scans the main package and all the folders inside it, looking for special components like your @controllers and @services. This is the very reason why all Spring projects have that same predictable structure. The framework is using the package system to configure itself automatically. It's pretty amazing.
So the really important thing to take away from all this is simple. We started off asking, why is Java so strict about folders? And the answer is because packages are so much more than just folders. They are the fundamental architectural tool that Java gives you to build software that's robust, that can scale up, and that you can actually maintain without losing your mind.
It's a system that was designed from day one to prevent chaos, to let large teams of developers work together, and to provide the blueprint for the huge applications that literally power our world. So the next time you type out that package declaration, remember, you're not just following some annoying rule, you're plugging into a system of organized genius.